Thank you for coming. We're here to talk about a game we've been working on for a while called Super Dungeon Bros. My name is Kevin Tyner.
Ryan Adams.
So just an overview of what Super Dungeon Bros is and what we're going to talk about, actually. So we're going to talk about what Super Dungeon Bros is, kind of the process that we built it. So this is a post-mortem. Why we're using Unity networking and how it kind of interacted with everything else in the project. That's going to be kind of the main focus is Unity networking.
We're also going to talk about Unity events, UGUI, as well as actually developing for multiple platforms using Unity. And we'll just go over a little brief summary of all the things that we've learned and what you guys can kind of take away from this postmortem.
All right. So first, about React Games. This is the studio we work for. It's a small studio. It was founded in 2008. It's based out of Salt Lake City, Utah. The first game they made was a remake of Archon, a classic game for iOS and PC. Historically, we mostly do client work there, so a lot of client work. Super Dungeon Bros is the first one we've done that's really our own project, and it's kind of big scale like this. A lot of it's mobile games. And we love using Unity because it lets us develop for Android, iOS, Windows Phone, all these different platforms without having to rewrite the code base. Some of the games we worked on include Archon, Dragon's Adventure, all these, President's Run, Cyber Defense, and Monopoly.
Okay, so what is Super Dungeon Bros? Super Dungeon Bros is a roguelike dungeon brawler action beat 'em up game. We kind of took a little bit of elements from everything and just put together what we thought was the most fun. One of the more interesting parts about Dungeon Bros is the short time scale we built this game on. The original time scale was about 6 months. We're pushed a little bit extra. It's taken about 9 months, but we're really close to getting close to being done right now. In order to actually accomplish this ridiculous deadline for a game like this, we didn't really have the necessary assets and team size to be able to create new assets for the entire game and make all the new levels. So we decided to go with a procedurally generated dungeon. This lets us build some assets but then reuse them in a lot of different and cool ways. For the main part of the game, we actually have 4 different types of weapons, and then using these different weapons and combinations, and they interact differently depending on the different type of weapon you have. This plus the procedural dungeons lets us have a lot more play time for not as much necessarily development time.
And there's 3 different worlds. We have like a crypt bone world, a swamp world, and a nice world. So.
But another really cool feature about Super Dungeon Bros is the couch co-op as well as online play. So you can sit on the couch and play with 3 of your buddies, or you can get online with yourself or even a couple of your buddies on the couch as well and play with other people online. The current plan is to release in winter of 2016, and we're releasing for Xbox One, PS4, Windows 10, and Steam. So a little bit of history about the creation of this game. It started as a build for the UGUI Game Jam. We kind of came into it a little bit late on that. We started about like halfway through the Game Jam and worked most or less just after hours in our free time on the game while we were still doing client work. It was actually pretty cool. We used a lot of Archon assets and got a really fun game that we just thought was really fun. And we submitted to the Game Jam, and we didn't win. But we did actually come as runner-up for the best Couch with Friends game for the Game Jam. As far as that was concerned, we was kind of depressed about that, but still really loved the game we were making. We really felt passionate about it. Felt like we had some really good concepts. So we decided to kind of push forward a little bit and potentially be a UGUI release title. However, we didn't really have the budget for that as far as just team members and funding, as well as UGUI's release was underwhelming, to say the least. So Dungeon Bros is kind of placed on the back burner for a couple years. In that time, we decided to start up a Kickstarter, because Kickstarter is awesome. We've been developing it again just when we could work on it. We weren't actually working on it all the time. But when we had free time, we'd just work on this between our client work. So we got our Kickstarter up, we got our prototype ready, we got our demo ready. We even started the countdown for Kickstarter, and just as we were about to get ready to go, a publisher said they were interested in actually developing the game, and we kind of just put everything on hold. We stopped the Kickstarter, we cut everything else, and we were just kind of really hoping and banking on this one publisher, and the deal eventually fell through. So Dungeon Bros was actually placed on the back burner once again.
Everyone was kind of sad about that.
Yeah. However, last year, so in 2014, we were actually nominated for Game Connect. So we decided, okay, let's go at it again. We'll refresh all the assets, we'll rebuild the game, we'll go back at it as hard as we can. So we built the prototype together. Just about that same time, we'd actually been approved for our Xbox One licenses, and we got some Xbox One dev kits. So we're see, okay, we've seen how Unity works with Xbox One. We have a feeling that we can actually potentially do this. So let's see what it takes to actually put our prototype onto Xbox One. And miraculously, we got it all working in under a week. We went from just a regular PC Unity game to actually working on the Xbox One in under a week and shipped off to Gamescom, where we actually won Best Social Game award. So this actually allowed us to get a whole bunch of publishers interested in our game, and we eventually signed a contract with Wired Productions to actually fully publish the game, and we started development early this year, like February, January.
Yep, early February.
And the target platforms, again, Xbox One, Windows 10, PS4, Steam. We're actually doing a multi-region launch and in multiple languages.
It's the plan anyways. All right, so now kind of to meet, so that's the history. So as soon as we got back from Gamescom, we kind of tried to figure out how we were going to actually go about implementing this networking because we hadn't even really started thinking about it. And so there was a couple options about what we could use for it. Unity 5.1 was on its way out, and with Unity networking included. And it was either basically that or rolling our own networking solution across all the different platforms we were targeting. And Unity networking definitely seemed like the better option. We also got support from Unity directly for a lot of our stuff because we were going to be one of the first people actually using it, and they wanted someone basically to do a crash test of the networking to make sure that it was working. So we decided to do that, and within 3 weeks, so GDC was just around the corner, and Unity wanted us to show the demo at GDC working networked. And at the same time, Xbox approached Unity and said, hey, we want somebody to demo Xbox One and Windows 10 crossplay. So Unity said, hey, we've got these guys who are working on networking already, and our networking is going to support that. So at GDC, we were actually featured in both the Xbox and the Unity booths, and it mostly worked. We got all the core gameplay stuff working. There was some issues behind the scenes, but for the most part, it was playable and it was fun. We didn't get the Windows 10 to Xbox crossplay for that build, and we're still actually working with Unity trying to get that finished right now. But it's almost there.
Yeah, but we also noticed a few issues with that. This is a prototype. We were just starting the networking, and we were still working with the prototype game for this point, and we're already noticing a lot of potential issues with the Unity networking that we're going to maybe bite us in the butt later if we kept going at the same rate we were going.
So we come back from GDC, and we basically had a discussion that says, all right, look, we need to finalize some stuff in this game because we're not going to get it done on time if we keep working with alpha stuff. So we decided to switch away from the high-level API, which is what we were using, and which we got it up working in 3 weeks, to the Unity networking low-level. So it's basically just packets back and forth. But we're still using parts of the high-level stuff, so the actual connections between the clients, we're still going through the high-level, and that works great on top of the low-level. When we decided to use the low-level stuff, we kind of decided we also want to build our own pseudo kind of high-level on top of it, because we already had all this code, and we needed a way to actually integrate it without having to rewrite all of it to work over the network. So our networking engineer, I don't know if any of you guys have heard about the decorator pattern, but that's what we ended up using. It's this, does anybody know what the decorator pattern is? Yeah, so using that for networking was probably the smartest thing we could do for anyone who's not familiar with it. Basically, you have this data field, and it's just kind of wrapped in layers they're called decorators that apply extra behaviors to it. So when you access the inner field, it goes through all of them in order. So we can validate data and then synchronize it before it actually touches the main component. And this worked great for the networking because, so it's similar to Unity's, the high-level API sync var. We can just basically replace any field that we need to synchronize with these and wrap it with a synchronizer decorator, which we had 2 of. So we had the channeled synchronizer and just the basic synchronizer. And so every time that you changed the data and the network loop ran, it would pull the current value from the field and just propagate it out to all the other clients. The channeled one would actually record a history. So if you change the value 20 times inside of one network update, then it would actually pass the entire chain of events along so that we don't and that'll be important later, I'll show you, but
we don't want to miss anything.
Yeah, because we've got a lot of stuff going on behind the scenes with those. So And it was really easy to implement because using the fields versus just the regular data values didn't require any change in the actual code. So anywhere there was a float, you access it exactly the same. So it was perfect because then our network guy could be working on the networking, completely independent of everyone working on the gameplay stuff, since we're trying to get this done, 1 month on top of what we had already. And then also, once we started working with the networking decorators, we kind of realized how powerful they were just for other parts of the game, and we kind of repurposed them. So like this validator thing that I've got here, we ended up using in a lot of places, like where there's health, we can just say, all right, we'll wrap it in a validator from 0 to whatever the max health is, so like 100, so that when somebody tries to do damage to a player, we don't have to validate it anywhere else in the game. Same with like move speed. We have a whole bunch of movement speed modifiers. They can stack, they have durations. If we let those be handled internally by the decorators instead of in every single place where there's movement speed, then we only have to write it once. So it's just the same. It's components basically for individual fields, which I think is pretty cool, and we really liked it. They weren't perfect. The biggest issue we had with them was trying to get them to show up just in the inspector so our designers could use them without having to actually open scripts. Because we were using generics for them, and Unity is not the greatest with generics in the inspector. Also, because some of the actual decorators that we were using don't really make sense outside of the context of the running game. So what we ended up doing was just writing a decorator that just ran a coroutine that updated the value in the actual that showed up in the inspector and the field, and just kind of bound them together periodically. And that works all right. It could be better, but for what we had, it worked. So.
Okay. So the next part we want to talk about is Unity events. This was actually our first time working with Unity events and working with UGUI. We hadn't actually had really too much experience with that before. When we started with this, we're kind of a little bit tedious about it. We weren't really sure if we really wanted to jump full into the event system. So we kind of just tested out with the UGUI, see how it worked. We did a little bit of our combat system with some Unity events, and we were amazed with the results. We just kind of fell in love with them. We were really happy with what it was giving us. As we kept developing, the events have actually propagated themselves through most of our code base. There's very few things in the game that don't have events in them somewhere. For example, our UI is almost 100% event-driven. We've written a wrapper class for the entire Unity input system that uses events now. When we actually got to analytics, save data, missions, and achievements, having events power most of the game actually sped this up dramatically, and I'll explain a little bit later why, as well as a lot of our gameplay elements. For example, state transitions are event-based and event-driven. So one of the things we actually had to do right at the start, though, was write wrappers for Unity events. When we first started working with the project and the Unity events, there were some issues with them. For example, subscribing and unsubscribing in the middle of an event stack would actually cause issues. They weren't actually synchronizing properly. I believe all of the issues have been resolved in the latest versions of Unity, but at the time there was actual issues that we had to deal with. So we had to write our own events wrapper for that. But it actually lent itself really well to a lot of the things we wanted to do, and it gave us a lot of power over some other things. For example, we created a self-registering component. So basically what it does, if you have the proper delegate type inside a component, it will, when you attach that component onto any object in the game, the inspector will actually attach all of those delegate types and automatically link them up to the correct events in other scripts, either on that object in different components or in parent objects and components on those.
Which was great because the designers were somewhat good at best at actually hooking all these things up whenever they create a new prefab, so just having it kind of handle itself was fantastic.
Yeah, it saved a lot of just small mistakes that could have been potentially made by hooking up events, especially if you're hooking up a lot of things in the editor like we were. That was super helpful. So like I said before, it actually helped us really quickly implement analytics and save data. The way it did this is we actually created a way using our event wrapper to subscribe to an event type. So you could subscribe to, for example, damage events. So anytime a damage event would fire in the game, we would actually be able to subscribe to all of them at the start of the program. So whether or not it was actually an object had been created or instantiated or not, we would be able to subscribe to that event ahead of time. So what this allowed us to do is actually just write all of the analytics code in just one place and keep it all separated from the actual code itself. So we never had to go into any other components or any other scripts to edit the code there in order to apply our analytics. And then, of course, we could take all that data after it was parsed and populate our save data, our missions, and our achievements. However, we got a little bit ahead of ourselves. We got a little overzealous with our events, and they kind of started spreading everywhere. And if you worked with an event-driven project that has a ridiculous number of events, eventually debugging them becomes an issue. When they're everywhere and you don't actually have necessarily just a way to follow function calls anymore, it gets a little frustrating. So what we did was we wrote an event debugger window. What it does is, using reflection, it will track all of the events that are fired and log them out to an actual log. And keeping track of the caller, all of the listeners, and the event, actually the event name that's fired. Then we can use that at runtime and after runtime to actually click on those and see what components we're firing the events and where they are, and actually be able to see that in the hierarchy and actually in the editor. So that was super helpful. However, that wasn't the only issue that was caused by this.
Yeah, so all of our enemies and the player, it's all just big state machines for all of them. And the problem was that we decided to start triggering transitions between states with these events. And sometimes, if the conditions were right, you'd transition into a state and then immediately transition into another one. And these kind of propagated through. So in places where we're trying to synchronize where these events are starting, it started becoming a huge issue just trying to actually make sure the events were happening across all the platforms. So we ended up kind of pulling back on the events as a logic part of the game, as a driving force of the logic of the game, and just try to let it be more data-driven because it's a lot easier to synchronize just values over the network and then let those values invoke the events themselves when they change. And once we started doing that, it was a lot easier to kind of work with and go from there.
Okay, the next part I want to talk about is multi-platform development using Unity. So fortunately for us, since we're using Unity networking, we're actually able to share a lot of our code. And we did write separate backends for Steam, LidGrin, and Unity networking. But our front end was all the same. All of it was powered the same. So after you got past that one part of deciding which backend we were going to use, all the front ends the same. We didn't have to write any extra code that was platform specific actually in the game itself. This helped tons and tremendously. So if we hadn't actually had that, I don't think we would have been able to meet any of our deadlines at all, having to write separate networking for all the platforms. However, there are some things that are platform specific. For example, matchmaking, user control, and save data are the really big three ones that really hit us hard. You have to write separate independent systems for each of those for all the platforms. Matchmaking, the biggest issue there is the way that the lobbies and the users are actually set up and brought together is quite different on each of the platforms. So Xbox will do it different than PlayStation 4, and Steam will do it different from PlayStation 4 and Xbox. But once you have all the users together, we can just kind of set all those values and all the players who want to get together over the network. And once that's set and those connections are ready to be made, and we know who's going to be connected to who, Unity Network is just beautiful after that point. So once we get all that information to Unity Networking, it just hooks them up, and our networking's good to go from there. User control and flow. This is still just a console thing. So it contains users logging in and out, controllers being connected or disconnected. There's really just no way to handle that nicely between the different consoles that we could find. As well as save data. Save data is pretty similar, fortunately. A lot of the function calls are very similar. It's all asynchronous for all those platforms. However, there's slight parts that are just slightly different. The way Microsoft returns is different than the way Sony returns for a lot of their asynchronous calls. And we just couldn't have that be the same code to run all of that. So we did have to write separate, independent systems for each of those. But the best way we found to do that was actually just write an abstract interface that covered basically all of matchmaking. And then we just plug in each of those independent systems behind the screens, basically. And as we need them, we'd flip them out. And it made everything a lot easier.
Overall, having to have only three systems have differences between, 4 pretty different platforms. We were pretty happy with it. So
Unity made you made that really easy. However, I will give you all one big warning. A lot of these systems are not finalized. The SDKs are being updated not only by Unity, but still by Microsoft and Sony and Steam. So as you're writing these, you still need to be aware that your code's being well documented, concise, and clear is still really important, because there's a very high likelihood you're still going to have to go back and edit a lot of that code.
Those principles should translate to all of your code, but yeah, it's important when stuff's changing that frequently.
Yeah. So cross-platform. So currently Unity does support Xbox One to Windows 10 crossplay through the Unity networking. We're still working them, I think we said earlier, we're still working with Unity to get a lot of that finalized, but we do have a lot of very good progress and a very good baseline to go off of, and it's showing great work for us. The other thing that I just wanted to bring up really quickly, how many of you guys have done Windows Store apps before? So a couple of you guys. So then you're probably, at least those of you who've done it before, you're aware of the subset difference in .NET. For those of you who aren't, there's some differences in the way .NET works on Windows Store apps. You have to change a little bit of your code, such as like file I/O and threading. I just wanted to make sure you guys are aware of that, because Windows 10 builds are Windows Store app builds. So those are the same. But if you have any issues, just make sure you check all of your libraries that you are using and any of the code you get from the asset store. Make sure you check all that. And if you do need help on fixing that, there's plenty of third-party assets on the asset store itself for fixing any of those issues.
All right, so now just kind of in summary, some of the things that we feel like we did pretty well on this project and we'd try and do again is just make use of good design patterns, like the decorator pattern is applicable, and events when they make sense, but be cautious and don't overuse things or use things incorrectly. And actually on that note, make sure that everyone on your team is aware of what you're doing, because if you've got a couple people working with one pattern and doing things one way and a couple people working on another completely different way, and then when you try and finally bring them together, it's not going to work so well. So use design patterns, but make sure everyone's on the same page about it. Actually be willing to actually dedicate a good amount of time building real tools. Like we showed the event window debugger, but having real tools in the inspector, just kind of extending Unity stuff, speeds up time spent so much.
And Unity lends itself to being able to do that very well. So you're really shooting yourself in the foot if you don't actually go back and implement a lot of those features for your design teams, or even just for yourself.
Then embrace third-party assets. That one's pretty self-explanatory. So we're using a pathfinding and the dungeon generation itself, our third-party assets, just because with the size of our team and the scope of the project, we wouldn't feel confident, especially on all the platforms, just making sure it all works. Having stuff already available is like having another member on your team. Just only pay them once for a couple $100. It's worth it. And then, so what we're saying is basically abstract all the low-level and platform-specific stuff, which just makes it really easy for multiple members of the team to work on separate parts of the project without actually having to wait for each other to finish with their stuff. You can just say, all right, look, this is just basic.
Good coding practices.
Right, good coding practices.
Yeah.
You want to say, all right, this is going to do this is going to do this, and then we can just throw them together, and it'll work without having to fight each other. And some of the things we do differently next time. Invest more time into maintaining the actual code base. So if you remember from our schedule, the first 3 months of development, every other week we were making a new build or for a new demo and changing the core gameplay so much that by the end of that, we just basically had a giant mess of spaghetti code. And we were able to kind of come back from that a decent amount, but there's still some stuff in there that I'm afraid to look at. And it's hard to maintain. So if you just kind of do it incrementally, every time you're making a new build, branch off and don't merge the entire thing back into development when you're done with it, just only the stuff that's actually going to be used. Profile throughout the entire process. So this one especially, we were getting upset at Unity for about a month because we had all of our procedural rooms that get meshed together. They're all stored as a reference in one object, and we had that in our startup scene. So whenever you'd open the game, or whenever you'd open Unity to try and start working, it would take 3 full minutes for it to actually open. And everyone was getting upset, and I finally said, all right, look, nobody else is reporting problems about this, because we were on the alpha and beta builds of Unity, so we didn't think it was necessarily our fault.
We just assumed it was Unity's fault.
But then we decided to go in and actually profile what was going on, and loading 500 megs every time you open Unity is not going to be the best thing, especially when they have self-references to each other. So use assets and stuff, but if we started that process a month earlier, 20 people times 3 minutes times every time you open Unity or press play is a lot of time wasted. So we're not trying to say don't go overboard trying to like pre-optimize, but definitely spend at least a little bit of time looking at what's going wrong, because that was a lot of time wasted. And then probably the biggest one, the most relevant one for this one is, if you're going to make a network game, plan for it from the start, because it's a lot easier to build all your stuff with the expectation of having to network it than having to integrate networking into an already existing code base. The decorator pattern actually made it pretty straightforward for us, but it was still, we had to do it that way instead of just using the high-level stuff, because the way our game was structured, the way that everything happened, just didn't support it without like rewriting huge portions of it that we just didn't have time to do. So,
awesome. Well, thank you guys for all coming. If you have any questions, we'd be more than happy to ask. If you want to check out Super Dungeon Bros, the link is up there, as well as our email addresses. Thank you.
Cool.
Any questions? Okay, here we go.
So you said that you were still working with Unity on the cross-platform work. What is it that is still causing issues that you had to work directly with Unity with the API already public?
Well, you answer that one.
So it's mostly just the functionality is not 100% finished on there, and there's just bugs in the actual cross-play network code that just hasn't been resolved yet. So we're just kind of waiting for them to finish before we can actually get it working 100%.
Cool. Thank you.
All right, thank you.
Thank you.